Okay, guys, 1.7 continued. We did linear inequalities. Now I want to look at some higher order inequalities. And the idea behind these is, suppose I have this right here. This is quadratic, okay? And it's equal to 0, okay? But what I want you to realize is that at the zeros, which I've put here, 0 and 2, whatever makes this thing equal to 0, and actually this is supposed to be a minus, sorry. Okay. That is when the sign of this thing can change. So for example, if we take, let's say, x equal to -1, we have -1 times -1 minus 2, and that is equal to, that's a negative times a negative, that's something positive right here, okay? So please ignore this top part. So our answer is positive. But notice once we cross 0, which is one of the zeros here, and we go to 1, so if x is equal to 1, we get 1 times 1 minus 2, which is a positive times a negative, which is negative. So we switch to a negative. And if we go to the other side of this 0, the 0 of 2, and let's say we use x equal to 3, we have a positive times a positive, which is positive. So what I'm saying is the zeros of this are where the sign changes can occur. Now, it won't always happen. For example, if this was x squared, sometimes you would not get a change right here. Okay, so you do have to check each side. The zeros just tell us what the boundaries are. Okay, so using that idea, I'm going to do this example. Solve each quadratic inequality, write the solution set in interval notation. So notice everything is greater than 0. That's what we want. It's just like the equation where we want everything equal to 0. We just have everything greater than 0. And I'm going to factor if I can. And I notice that x minus 5 and x minus 2 works. And that's greater than 0. Now, we want to keep in mind we want things greater than 0, which means we want positive things. Okay? So our zeros, you can see from here, are at x equal to 5 and 2, whatever could make this equal to 0. So what I'm going to do is I'm going to draw a number line, and I'm going to mark off at 5 and 2. And I'm going to pick points on either side. So 2 and 5 are my zeros, so I know that's where the sign change from positive to negative or negative to positive could occur. And if I choose the value of a 0, I have 0 minus 5, which is a negative, and 0 minus 2, which is negative. So I don't care about the actual value. I just want to know if it's negative or positive. I know a negative times a negative is a positive. Okay. Now, if it's actually equal to 2, will that satisfy greater than 0? No. So I'm going to put an open circle there. How about in between? What if I try, say, 3? Well, if I try 3, then 3 minus 5 is negative, and 3 minus 2 is positive. A negative times a positive is negative. At 5, it would be equal to 0 for x. So I'll put an open circle because it can't be equal. It's strictly greater than. If I choose a point out here, say 10, I get a 10 minus 5 is positive, 10 minus 2 is positive, and I get something that's positive. So what do I want to shade? I want to shade all the positive stuff, all the stuff greater than 0. So I want all of this stuff, and I want all of this stuff. So the question is, how do I write that in interval notation? Well, in interval notation, I read it left to right, just like I have been, from negative infinity to 2, but not including. And now I'm going to put this symbol here. What this stands for, it's union. It means, you can think of it as and. Okay, so I have negative infinity to 2. Okay, I have to cut out the middle, and then I have 5, not including, to infinity. There is my final answer. That's everything, every value of x that satisfies this. Let's look at B. Negative x squared minus 6x minus 16 is greater than or equal to negative 8. Now, we don't have everything greater than or equal to 0, so that's what I'm going to fix first. So I have negative x squared minus 6x minus 8 is greater than or equal to 0. And now I'm going to look to factor this. But it's not so nice having a negative here. So what could I do? Multiply both sides by -1. Okay, that way I won't have the negative out front. So I'll multiply over here by -1 and multiply over here by -1. What do I have to remember to do if I do that? I have to remember to flip the sign, right? Then I'll have x squared plus 6x plus 8 is less than or equal to 0. And that's very easy to factor. And now I want things less than or equal to 0 or negative or equal to 0. So I'll do the same thing. What are my zeros? My zeros are -4, -2. So that's what I'm going to put on my number line. I have -4 and -2. These are where the possible sign changes could occur. Pick a point over here. How about -10? That would give me -10 plus 4 is a negative, and -10 plus 2 is also a negative. Negative times a negative is positive. Okay. Now, -4 and -2, can I include those in my answer? Well, yes, I can, because it's less than or equal to. And we know at the zeros, that's when it's equal to 0. So I'll go ahead and I'll just shade these right now. Let's pick a point in between. I guess -3 is a good choice. -3 plus 4 is positive. -3 plus 2 is negative. Positive times negative is negative. I want negative stuff, so I'm going to shade this. And I know that from this symbol right here. Okay. I go over here, let's say 10. Positive, positive. Positive times positive is going to be positive. I don't want that. So how do I write my final answer in interval notation? Well, I just want -4 to -2. I want to include both of those. And there are some higher order inequalities.